Welcome, my dear learners, for this course on dynamics of machines. In this module 3, we were discussing on governors and gyroscope. In our previous lecture, we have solved two numerical problems on Hartnell governor. Let us continue our discussion on problems on Hartnell governor. The problem number 3 of our discussion on problems on Hartnell governor states that a spring-loaded governor of the Hartnell type has arms of equal length. The masses rotate in a circle of 130 mm diameter. When the sleeve is in mid position and the bell arms are vertical. The equilibrium speed for this position is 450 rpm, neglecting friction. The maximum sleeve movement is to be 25 millimeters and the maximum variation of speed taking friction into account is to be plus or minus 5% of the mid position speed. The mass of the sleeve is 4 kg and the friction may be considered equivalent to 30 Newton at the sleeve. The power of the governor must be sufficient to overcome the friction by 1% change of speed either way at mid position. Neglecting obliquity of arms, determine the value of each rotating mass, the spring stiffness, the initial compression of spring. Now let us solve this problem, which involves considering of friction into account. If we restore the data given for us, a spring-loaded governor of Hartnell type has equal arms. That is, ball arm and sleeve arm are equal. It is not specified how much is that. The masses rotate in a circle of diameter 130 mm when the sleeve is at mid position. So if the diameter is 130 mm at the mid position, the radius will be 130 by 2. So therefore, at mid position the radius is 65 millimeters, which is 0.065 meters. The equilibrium speed at this position N is 450 rpm, neglecting friction. The maximum sleeve movement is to be 25 mm. So is given h, that is h1 plus h2 is 25 mm, and the maximum variation of speed taking friction into account is to be plus or minus 5% of the mid position speed. That is, n1 is equal to n minus 5% of n, and n, therefore calculate what is the value of n1, and n2 is n plus 5% of n. Calculate the value of n2. So if we determine, I am going to get 450 minus 5% is 5 by 100 into 450. That is, minimum speed is turning out to be 427.5 rpm, whereas maximum speed will become 472.5 rpm. So minimum speed is 427.5 rpm and maximum speed is 472.5 rpm. So this is what plus or minus 5% variation of speed considering friction into account. The mass of the sleeve is 4 kg, that is capital M is 4 kg, and the friction may be considered to be equivalent to 30 newtons. Friction is specified, which is 30 newtons. The power of the governor must be sufficient to overcome the friction by 1% change of speed on either way at mid position. So it's given at mid position. At mid position, the variation of speed is plus or minus 1%, considering friction into account. So therefore, at mid position, let me take the minimum speed as n1, or let me call it as n dash and n double dash. N dash is mean position minimum speed, that is n minus 1% of n. So n minus 1% of n is how much? That is 450 minus 1 by 100 into 450. That is 445.5. 445.5 rpm, whereas n double dash is n plus 1% of n. that is 450 plus 1 by 100 into 450, which is 454.5 newtons. Sorry, 454.5 RPM. What else has changed? Neglecting obliquity of arms determine the value of rotating masses. So mass of each ball is not known, spring stiffness is not known, and initial compression, that is H1. H1 is asking initial compression. H1 is also not known. Let us determine this values. So if I draw the line diagram first, we have to understand the problem. We have the axis of rotation of the Hartnell governor. Axis of rotation of the Hartnell governor. Now at the mean position, let us take the mean position. The arm lengths are equal, we said. Let me take the arm lengths are equal. This is good. Now we have minimum position and maximum position, right? Let me have the minimum position. Let me use dotted line for minimum position, and let me use dashed lines for maximum position. That is maximum speed position. So this is what we have, and this is x and y. X is equal to y, he stated. Now what else he has specified? Here the force will be how much? mg plus s1 minimum position minus friction divided by 2. So here the force is mg plus s2 plus f by 2. This we have already done. Here the force is how much? mg plus s2 plus f divided by 2. This is the force acting. Now here you know mg acts downward, fc acts horizontally outward. So this we have already learned. This is the direction of fc, fc1, fc2. So this is position 1 and this is position 2 and this is mean position. Now we want to determine mass of the ball and stiffness of the spring and also initial compression of this spring. Now a careful observation will reveal that without mass of the ball I cannot determine what is the centrifugal force at these two positions. Correct? Because centrifugal force depends on mass. It is m omega square r. Now if we take moment about O for these two, apart from mass, because even though I neglect mass, mg acting downward, because he has stated neglect obliquity effect. If I neglect obliquity effect, mass of the ball when you take moment must be neglected, and obliquity effects, that is x1 and y1, are all equal to x and y. This you people already learned. But to calculate fc I want small m, correct? So when I take moment at this point, small m will be included in fc, and we have s1 and s2, two unknowns. We don't know what is the value of s1, we don't know what is the value of s2, and we don't know what is the value of small m. But we will get only two equations. One is for minimum speed, one is for maximum speed. But how many unknowns are there? Three unknowns are there. S1, S2, small m. But how many equations are there? Only two equations. Take moment about O for maximum speed position. Take moment about O for minimum speed position. You have two equations with three unknowns which cannot be solved. So therefore, another possibility is that if I solve for mean position. If I solve for mean position, what happens? Here, if I solve for mean position, he has given two speeds for mean position. Here we have mg plus s plus or minus f by 2. Correct? mg plus s plus or minus f by 2. When I take plus f, the speed is 454. When I take minus f, the speed is 445.5. When I take f as 0, the speed is 450. So at the mean position itself, we have three speeds. Neglecting friction, accelerating friction minimum speed, accelerating friction maximum speed. At the mean position itself, we have specified three speeds for us. So therefore, what I will do, I will take moment about O for minimum speed, maximum speed. Then in both the equations, S will be there and M is the another unknown. So I get two equations with two unknowns which can be solved. Hope what I explained is clear. So therefore I should go for mean position first. If I go for mean position, the only unknown is S when I take moment, and the unknown is mass M, which is inside Fc, that is M omega square R. So therefore solve for mean position first. That is to find ball mass, solve for mean position. So to find ball mass, solve for mean position. Solve for mean position. So for mean position, if I take Fc dash is how much? Fd dash is M omega square, that is 2 into pi into n dash by 60 whole square into radius remains same, right? Radius is r only. So how much you are going to get? Mass of ball is unknown. It is 2 into pi into n dash. N dash is 445.5 by 60 whole square into radius is 0.065. It is 141.47. 141.47 meters. And Fc double dash is how much? M times 2 pi n double dash by 60 whole square into R. How much is Fc double dash? It will be, sorry, here M is not known. No? I want to find the value of M. So multiply this by M. M meters. Here only change the speed. So the change of speed, that is maximum speed, is 454.5. So Fc double dash is 147 M meters. 147 M meters. So mass is left out in Fc. Now take moment about O for maximum speed, take moment about O for minimum speed at mean position. So that is, if I take moment about O, moment about O for mean position, maximum and minimum speed. For mean position, maximum and minimum speed. So you get two equations, right? One is for maximum speed, what I will get? Mg plus S plus F by 2 into length is y. This must be equal to Fc double dash into x. This is for maximum position. And for minimum position, what you will get? You will get Mg plus S minus F for minimum position into y. This must be equal to Fc dash into x, because one is causing clockwise, one is causing counterclockwise movement. Now to solve these two equations, I want mass. Let me solve these two equations with unknowns. Substitute whatever we have and check out what I am going to get. Mg is known for us. S is not known. F is known. Y and x will get cancelled. Correct? Because both are equal. Y and x will get cancelled because both are equal. X is equal to y given for us. Hence, I will get Fc double dash. Fc double dash is 147 m. So you get 147 m. Fc double dash is 147 m is equal to mg plus s plus f by 2. That is, let me multiply 2 this side. To avoid confusion, let me solve properly. I multiply 2 this side. That is 2 times Fc double dash will be equal to mgs plus f. Mass of the slip is 4 kg with 9.81 plus friction is equal to 30 newtons. Friction is equal to 30 newtons. If I solve, I will get 69.24. 69.24. Yes. 69.24. Yes. Similarly here, if I solve, what I am going to get, this is equal to 2 times Fc dash, that is mg minus f, that is 4 kg is capital M into 9.81 minus friction force is 30 Newton, which is 9.24 plus S. This is S plus, right, be careful. This is S plus 69.24, correct? Mg plus F is known, S is unknown. Mg minus F is known, S is unknown. Now what I will do, I will take this as equation 1, I will take this as equation 2. Now I will subtract equation 1 minus 2. Taking equation 1 minus equation 1 minus 2 I will do. S and S will get cancelled. I will put with 69.24 minus 9.24 will be equal to 2 times Fc dash, that is 2 times 147 minus 2 times 141. I will take M common. Therefore, mass of each ball will become how much? 69.24 minus 9.24 divided by 2 into 147 minus 2 into 141. 5 kg. So this is equal to how much? 5 kg. So we have got the mass of each rolling ball. It is coming out to be 5 kgs. Now to find the spring stiffness, I want the general expression, that is S2 minus S1 by H. H is already known. Total lift is given 25 mm. This H is already known to me. So H is already known to me. Overall H is already specified for us. So therefore I should find S1, S2 and H, where S is force exerted. So now taking moment at O, A for maximum speed, that is for dash length, that is at 2, this one. So one we have mg plus s2 plus f by 2 into negative obliquity effect y fc2 into x, that is mg plus s2 plus f by 2 multiplied by y must be equal to FC2 into X. So cancel of X and Y. Cancel of X and Y. Now what you are left out with? You are left out with S2 only, right? So what is the value of S2 you are going to get? S2 will be equal to 2 times FC2. What is the value of FC2? M omega square, that is 2 pi m2 by 16 whole square into R2 minus mg minus f minus mg minus f. This is what I have. What is the value of R2? R2 is not known. So therefore form similar triangle and find out what is the value of R2. This is position 2. This is position 1. Let's take it as ABC. This is D, E, F. So from triangle ABO and DEO. From triangle ABO and DEO. From triangle ABO and DEO. I can write how much is AB? AB is R2 minus R. R2 minus R by X will be equal to, this is H2. H2 by Y. So you know all the values, find the value of R2. R2 will become, H2 is half of H. So half of H is how much? 0.0125. 0.0125. X and Y will get cancelled. Plus R. Plus R. R is 0.065. 0.065. So therefore R2 is okay. R2 is how much? 0.0125. That is H by 2. 25 mm by 2 is 12.5 mm in terms of meters I am writing. Plus the radius is 0.065. 0.065. Which is 0.0775 meters. Hence I will get the value of S2. So how much is S2? S2 is how much newtons? Substitute all the values. 2 into M. M is 5 kg into 2 into pi into N2. N2 is 472.5 by 60 whole square into R2 is 0.0775. This answer minus mg. M is 4 kg into 9.81 minus F is 30 newtons. So therefore S2 is certainly going to be 1828.2 newtons. Now B for minimum speed. For minimum speed. If I take it for minimum speed, what I am going to get? mg plus S1 minus F by 2 into Y must be equal to FC1 into X. Cancel of X and Y. So we get the expression for S1. S1 will be 2 times M into 2 pi N1 by 60 whole square into R1 minus mg plus F. Minus mg plus F. Now from triangles BCO and EFO. From triangles BCO and EFO. From triangles BCO and EFO, I can write R minus R1 by X is equal to H1 by cancel of X and Y. So therefore R1 is equal to H1 is half of it, 0.0125, half of total sleeve movement by plus, sorry, R minus H1, right? So we get R minus H1. R is 0.065, R minus H1. H1 is 0.0125. So we get the value of R1. How much is R1? 0.065 minus 0.0125. R1 is 0.0525. 0.0525 meters. Hence I get the value of S1. So force exerted by the spring at minimum speed. S1 will be, solve this equation. 2 into 5 kg into 2 into pi into N1. How much is N1? 427.5 by 60 whole square into R1. R1 is 0.0525. This answer minus mg. Capital M is 4 kg into 9.81 plus 30, which is 1043 newtons. So therefore I got spring stiffness as S2 minus S1 by H. S2 minus S1 by H. 25 mm. So S2 is 1828.2 minus S1 is 1043 divided by H is 25 mm. Let me put it in meters, 0.025 is 31408 Newton per meter, and initial compression is equal to force by stiffness, that is S1 is initial force by stiffness is small s. So initial force S1 is how much? 1043 by stiffness is 31408. So S1 by stiffness is the initial compression, S2 by stiffness is the final compression of the spring, and this turning out to be 0.0332 meters. 0.0332 meters. So this is the final answer for this problem. So the stiffness of the spring is 31,408 Newton per meter, and the initial compression is 33 millimeters. 33 millimeters, and this is spring force, initial spring force at maximum speed, and mass is turning out to be 5 kg. So this is the complete solution for problem number 3. This is how we should solve the problem whenever it is asked us to calculate or solve the problem by considering frictional force into account. Unless otherwise specified, always you neglect the obliquity effect. Whenever you neglect the obliquity effect while calculating the moment, don't consider the ball mass into account. That is what you should do whenever he has specified neglect obliquity effect, or he has not specified anything about the effect of obliquity, we always neglect the obliquity effect. If and only if he states to take the obliquity effect into consideration, then only you should take the obliquity effect and the ball mass for calculating the moment about the fulcrum point, that is at O, which I clearly explained during the derivation of spring stiffness for Hartnell curve. That's all from this lecture. Thank you all.